Now let's continue solving linear inequalities. Here our variable is on both sides of the inequality. Now in a case like this, I would recommend following the procedure I use with linear equations and having the single variable term on the side with the greater coefficient. And the reason for that is, if I subtract p from both and get positive 1p, then I don't have to worry about dividing by a negative number. I don't have to worry about changing the inequality symbol. On the other hand, if I subtract 2p from both sides, I'm going to have a negative 1p on the right. Then I am going to have to worry about changing the inequality symbol when I divide. So please solve this inequality and answer using a graph and interval notation. And let's continue with the strategy that when we combine to a single variable term, we'll go to the side with the greater coefficient. First, I'm going to subtract p from both expressions and simplify. Next, I'm going to add 9 to both expressions and simplify. I'm looking for values that are less than 4. Here's my number line, and here's my interval notation. See if you can do this one. Remember our strategy for fractions. Find the LCD and multiply both expressions by the LCD. The LCD for both expressions would be 28, so I multiply both by 28. Then I distribute 28 to the numerators. On the left, 28 divided by 4 reduces to 7. On the right, 28 divided by 7 reduces to 4. After distributing, I'm going to collect my variable terms first on the left, since 7 is greater than 4. After subtracting 4y from both sides, I'll have 3y on the left. Next, I'm going to add 28 to both sides. Now, sometimes students get uncomfortable here because, well, that's going to be a 0. It is, but 0 is a fine number. So after adding 28 to both expressions, I get 3y on the left, 0 on the right. Last, I'm going to divide by 3. I don't have to change the inequality symbol because it's a positive 3. So I'm looking for values that are less than or equal to 0. Here's my number line, and here's my interval notation. Let's practice now where we do have to change the inequality symbol. I'll do the first one. To solve this for x, I'm going to divide both sides by negative 3. But notice when I do that, I have to change the inequality symbol at the same time. Don't hold off doing it till the end, because often people forget by the time they get to the end. So on the step where you divide by a negative value, that's when you want to change the inequality symbol. On the left, negative 3 divided by negative 3 will be positive 1x, which is just x. On the right, I'll get 5. Here's my graph. Here's my interval notation. Because we're not equal to, make sure you're using a parenthesis. Try this one. After distributing and subtracting 5 from both expressions, I'm going to divide both expressions by negative 5, which means I need to change my inequality symbol. After simplifying, I'm looking for values greater than 2. Here's my graph and my interval notation. Here's another. Step 1 would be to distribute and get negative 8 minus 4x. On the right, I can collect like terms to get a negative 2. Since my variable term's already on the right, I'll just keep it there. My constants will go to the left. I'm going to add 2 to both sides. Last, I'll divide by negative 4, but I'll remember to change the inequality symbol. And I'll find I want values which are greater than or equal to negative 4. Here's my graph and my interval notation. For this problem, even though our strategy so far has been to add 2p to both sides so that we have a positive coefficient, I'd like you to solve this one by subtracting p to both sides, just to show that you can do it as long as you know how to handle a negative coefficient. Give it a try. After subtracting p from both and subtracting 1 from both, I'm going to divide by negative 3, which means I need to change my symbol, and I'll end up with p has to be greater than or equal to 2. Here's my graph and my interval notation. For this last couple, let's return to the idea that we ended linear equations with. That is, sometimes all the variables are going to go away, and then you either have something which is true or false. An identity or a contradiction is what we called them back with linear equations. See if you can figure out the way to think about those with inequalities. For this problem, I would first have to distribute the 3. Then, on the left, I would simplify to just v plus 3. Notice now, though, after subtracting a v from both sides, I'll get to here. My variables are gone. This is a true statement, though, and that's trying to tell me that I can select any number I want for v, and this inequality is going to hold after I simplify. That means my solution is the entire real number line, and I can choose any value from negative infinity to infinity. Here's our last one. See how you do. After distributing, I'll get 12m plus 30. 12m minus 7m will be 5m. After subtracting 5m from both, I get a contradiction. 0 isn't greater than 30 or equal to it. That means we have no solution here. And I'll show you another symbol for no solution. It's this one. That implies you have an empty set, that there's no elements in the solution set. Well, that concludes our work with solving linear inequalities.